At any given moment, millions of asteroids of varying shapes and sizes drift through our solar system. Most of these cosmic rocks are located in the asteroid belt between Mars and Jupiter, but many have orbits that bring them close to Earth. The problem? We don't actually know exactly how many are out there. Every year, scientists discover more asteroids, mapping their trajectories and assessing the potential risks they pose to our planet. Here are 5 asteroids that have astronomers especially concerned. But before starting the video, be sure to smash the like button and subscribe so you never miss out on our upcoming videos. Number 5. 1990 MU, a giant on a dangerous path. Discovered in 1990, the asteroid known as 1990 MU is one of the larger and more concerning near-Earth objects currently being tracked. Its estimated diameter ranges from 1.66 to 3.7 miles, 2.7 to 6 kilometers, placing it firmly in the category of potentially catastrophic asteroids. 1990 MU travels at a staggering speed of approximately 23 kilometers per second and takes about 754 days to complete one orbit around the Sun. The asteroid's classification as a potentially hazardous asteroid, PHA, stems from 2 main factors: its size and its orbit. Objects larger than about 500 feet, 150 meters, that pass within 4.6 million miles, 7.5 million kilometers of Earth are categorized as PHAs. 1990 MU fits both criteria, and its future close approaches warrant serious attention. In one of its predicted near passes, 1990 MU could come within about 2.8 million miles of Earth. While that distance might seem reassuring, it underscores just how close and how large these cosmic threats can be. A collision with an object the size of 1990 million meters would be devastating. It would release an amount of energy millions of times greater than the most powerful nuclear weapons ever detonated. The immediate effects would likely include massive shock waves, tsunamis if it impacted an ocean, and fires ignited by the intense heat generated during impact. Longer-term consequences could involve dust and debris thrown into the atmosphere, leading to years of disrupted climate patterns and massive losses in global agriculture. Currently, there is no indication that 1990 MU will strike Earth in the foreseeable future. However, the chaotic nature of orbital dynamics, gravitational influences from other planets, and non-gravitational forces like radiation pressure mean that predictions must constantly be updated. NASA's planetary defense teams monitor asteroids like 1990 MU carefully, and advancements in tracking technology have significantly improved the accuracy of future predictions. 1990 MU serves as a stark example of the kinds of threats lurking in the solar system. While it is comforting to know that its path is being closely watched, its very existence underscores the need for continued investment in asteroid detection, deflection technologies, and international cooperation to ensure Earth's safety. Number 4. 3122. Florence, a giant among near-Earth asteroids. On September 1, 2017, Earth had a close encounter with a behemoth asteroid named 3122 Florence. Flying by at a distance of just 4.4 million miles, Florence set records as the largest asteroid to pass that close to Earth since we started tracking these objects. Measuring an enormous 2.7 miles in width, Florence belongs to a category called Apollo-class asteroids, meaning its orbit crosses Earth's path around the Sun. Fortunately, during this 2017 encounter, there was no risk of collision. Even better, scientists have mapped Florence's trajectory and determined it won't threaten Earth for at least the next few centuries. However, Florence's sheer size makes it terrifying to think about. Scientists consider any asteroid larger than 0.6 miles across as capable of causing global catastrophe. If Florence ever were to hit Earth, it could wipe out civilizations, trigger climate changes, and drastically reshape life on our planet. Even though it missed us comfortably in 2017, its ability to reappear periodically keeps it firmly on the radar of astronomers worldwide. Florence is a perfect reminder that even if an object misses us once, orbital changes over time can alter future paths in unexpected ways. Number 3.1998 QS52, the colossal threat we can't ignore. 1998, QS52 is another asteroid that has attracted significant attention from astronomers. Discovered on August 25, 1998, by the Lincoln Near-Earth Asteroid Research Linear Project, this colossal object falls into the category of Apollo-class asteroids, meaning it crosses Earth's orbit as it travels around the Sun. What makes 1998 QS52 particularly alarming is its sheer size. Estimates suggest it could be between 2.5 and 5 miles 4 to 8 kilometers in diameter, making it significantly larger than most near-Earth asteroids. Scheduled to make a relatively close approach in 2038, 1998 QS52 will pass within about 7 million miles of Earth. While that might sound like a comfortable margin, in astronomical terms, it is still considered a near miss. Objects of this size traveling at tens of thousands of miles per hour carry unimaginable destructive potential. A collision with 1998 QS52 would be catastrophic on a global scale, likely causing immediate mass extinctions and long-term environmental impacts that would change life on Earth forever. What worries scientists even more is the nature of the asteroid's orbit. 1998 QS52 has a highly elliptical trajectory, which means its path around the Sun is far from circular. This eccentric orbit makes its movements less predictable, and small gravitational tugs from other planets or even subtle forces like the Yarkovsky effect, where uneven heating from the Sun slightly alters an asteroid's course over time, could shift its trajectory enough to increase the risk of an impact in the distant future. Current models suggest that 1998 QS52 does not pose an immediate threat. However, because of its size and unpredictable orbit, it remains a high-priority object for ongoing observation. Astronomers use radar and optical telescopes to track its path with increasing precision, and future close approaches will offer valuable opportunities to refine impact probability models. In the meantime, 1998 QS52 serves as a chilling reminder that some threats are massive, hidden in the dark, and waiting for their moment in our cosmic neighborhood. Number 2. 99,942 Apophis, the asteroid that terrified scientists. Few asteroids have captured the public's imagination and scientific concern quite like Apophis, officially designated 99,942 Apophis. Discovered in 2004, initial observations suggested there was a startling 2.7% chance it could collide with Earth in 2029. This was a shockingly high probability for such an event and caused widespread alarm both in the scientific community and the public. Apophis is relatively small compared to some of the giants on this list, measuring about 1,100 feet, 340 meters in diameter. However, even an asteroid of this size could cause catastrophic regional damage if it were to impact Earth. Early calculations suggested that an Apophis impact could release energy equivalent to more than 1,000 megatons of TNT, enough to destroy entire cities and cause widespread devastation across hundreds of miles. Fortunately, more detailed observations and calculations have since ruled out an impact in 2029. Nonetheless, Apophis will pass incredibly close to Earth on April 13, 2029, at a distance of about 19,600 miles, 31,500 kilometers, from the surface. This is closer than many geosynchronous satellites orbiting our planet. During this flyby, Apophis will be visible to the naked eye from parts of the Earth, appearing as a bright moving star across the night sky. The close pass in 2029 presents both an opportunity and a challenge. Scientists will have an unprecedented chance to study Apophis up close, potentially gathering valuable data on its composition, structure, and behavior. At the same time, there is concern that Earth's gravity could slightly alter Apophis's trajectory, which might increase the chance of a future collision decades down the line. Monitoring this flyby will be crucial to updating future risk assessments. Apophis has already taught scientists and the public important lessons about the dangers posed by near-Earth objects. It highlighted the need for rapid detection and precise orbit calculation, and spurred greater investment in planetary defense initiatives. Even though the immediate threat has passed, Apophis remains a symbol of the thin line that separates everyday normalcy from potential catastrophe in our ever-changing solar system. Number 1. Asteroid 52768, 1998 OR2. In 2020, at a time when the world was grappling with the COVID-19 pandemic, headlines erupted with news about another looming threat from space. Asteroid 52768, also known as 1998 OR2. Discovered in 1998 by the Near-Earth Asteroid Tracking (NEAT) program, this enormous rock measures approximately 1.2 miles, 2 kilometers, in diameter. It is classified as a potentially hazardous asteroid due to its size and its orbit, which periodically brings it relatively close to Earth. On April 29, 2020, 1998 OR2 made a close approach, passing Earth at a distance of about 3.9 million miles, 6.3 million kilometers. While that distance is more than 16 times the distance to the Moon, the sheer size of the asteroid captured public attention. If 1998 OR2 were ever to collide with Earth, the results would be devastating on a global scale, unleashing unimaginable energy, triggering tsunamis, firestorms, and potentially altering the climate for years. One reason why 1998 OR2 drew particular concern is that its orbit intersects Earth's orbit regularly. Even though scientists were able to confidently rule out any impact during its 2020 flyby, future encounters will require continuous monitoring. Gravitational interactions with other planets or subtle non-gravitational effects could gradually alter its orbit over centuries, creating new risks. The flyby of 1998 OR2 provided an excellent opportunity for astronomers to refine their understanding of large near-Earth asteroids. Using radar observations, scientists were able to capture detailed images of the asteroid, revealing surface features such as ridges, craters, and possibly even boulders. Studying these characteristics not only helps in planning potential future deflection missions, but also offers clues about the history and evolution of our solar system. 1998 OR2 serves as a clear reminder that large space rocks are out there, many of which have yet to be discovered. Ongoing efforts to map and track these objects are vital for planetary defense. Programs like NASA's DART Double Asteroid Redirection Test and international collaborations continue to advance our capabilities to detect and possibly deflect dangerous asteroids before they pose a direct threat. While none of these asteroids currently pose an immediate threat, they are all sobering reminders of the cosmic dangers lurking in our solar system. With millions of asteroids still undiscovered, ongoing observation, improved technology, and international cooperation will be crucial in protecting our planet. After all, in the grand scheme of the universe, it's not a matter of if an asteroid will hit Earth again, it's a matter of when. Thank you guys for watching. If you want more videos like this, make sure to like the video and hit subscribe button, and we'll see you in the next one.